Hello everyone. This video is on the Knewton Alta assignment for section 12.3 part 2 called Parabolas Not Centered at the Origin. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same and the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you do the assignment on your own. Alright, so on the assignment page you should have the title, the mastery bar to tell you how far along you've gotten, your objectives. Looks like there are 3 objectives for this assignment. And under the current objective should be a question related to that objective. And at the bottom of every question should be a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. It's for instructors only. But you will have a more instruction button. Alright, so if you're ever struggling with a topic or a question, click on this and you'll be taken to a page with further reading or videos to study, and then given some questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so I know the title on my video is, parabolas that are not centered at the origin, but that shouldn't be, we should be talking about the vertex, not the center. Right. This is more proper. So write the equation, the first objective I'm looking at is write the equation of a parabola with its vertex not at the origin in standard form. Now I am assuming here that you have seen my video for section 12.3 part 1, where we were looking at parabolas that did have a vertex at the origin. In fact, I have what I drew from that video right here. We were looking at parabolas with a vertex at the origin, and we looked at 2 different cases. One where the axis of symmetry was vertical, or the y-axis, and in that case the equation in standard form was x squared equals 4py. Right, and the value of p told you where the focus and directrix were. Right, there was a special point inside the parabola called the focus, and a special line outside the parabola called the directrix. And whatever the value of this p was, told you where to go from the vertex to get to the focus and directrix. So, here if p is positive, the focus is at 0p, p units above the vertex, and then the directrix would be p units below the vertex. And the directrix is always perpendicular to the axis of symmetry. Now if p were negative, then the focus would be below the vertex and the directrix would be above, but by that p units. And the whole reason we found the focus and directrix was because of the definition of a parabola. Right? A parabola is defined as a collection of points whose distance from the focus and directrix are always equal. So if you take any point on the parabola, take the distance to this focus and the distance to this directrix straight to it, you go parallel to the axis of symmetry, those distances will always be the same. Right? And then we'd also discuss this segment that contained the focus that was parallel to the directrix, and the points on the end of that segment. That segment was called the lattice rectum. Okay, sorry about that. And then the lattice rectum, this segment containing the focus, the length of that is the absolute value of 4p, so whatever the coefficient of that y was, or x. Right? When the axis of symmetry was horizontal, right? It was the other way around. It was y squared equals 4px. But still the same stuff. The value of p told you which way the focus was. Or if p was positive, it was to the right of the vertex. If p was negative, it was to the left of the vertex. And all this, okay? So I'm going to draw a very similar picture here, but with just, this, all that's going to change when the vertex is not at the origin is just like when you had ellipses and hyperbolas with centers, at the origin versus centers not at the origin. X is replaced by the quantity x minus h, and y, all the y's are replaced by the quantity y minus k to move the vertex from the origin to a point hk. Right? So here we have parabolas. Parabolas with vertex at the point h comma k instead of 0, 0. And just like with the last video, right, just like with section 12.3 part 1, this is getting kind of faint, sorry. We're going to look at two different cases, one where the axis of symmetry is vertical, right, that line containing the focus and vertex that cuts the parabola in half, right, the axis of symmetry. So one where the axis of symmetry is vertical or parallel to the y-axis. So in that case, I can say the vertex, here's the xy plane, the vertex is at some point h comma k, like this. And then I'm just going to put the one opening up. Just know that they can open down as well. And the equation of such a parabola is going to be x minus h squared, some quantity x minus h squared equals 4 times p times another quantity in parentheses with y minus k. Right. So this is the equation in standard form. Just like in 12.3 part 1, only x is replaced by x minus h, y is replaced by y minus k. Now, suppose you find p and p is positive. Well, that'll tell me that the focus is p units above the vertex. So I go from k to k plus p, and here's the focus of the parabola. We got the vertex there, and then p units on the other side, so k minus p. There's going to be this directrix. Right. Again, the axis of symmetry is vertical. I'll draw the axis of symmetry first, right? The axis of symmetry is x equals h, right? And the directrix is always perpendicular to this. Right? So there's this directrix perpendicular to the axis of symmetry. And it's a horizontal line, so it's going to have y equals some number, y equals k minus p. And then you have these points at the end of the lattice rectum. Right, I wrote this last time too, but remember the lattice rectum has a length absolute value of 4p. Whatever 4p is here, make it positive, and that's the length of this lattice rectum segment. So we use symmetry. We go 2a, I go 2p to the right, say h plus 2p, and 2p to the left, h minus 2p, and then draw some points in line with the focus, and those are the ends of the lattice rectum. H plus 2p, comma k plus p, and h minus 2p, comma k plus p. Those are the ends of the lattice rectum. And then once you have the vertex and the ends of the lattice rectum in, you can draw a parabola, a rough sketch of the parabola. Right, I should label everything. Alright, so here's the vertex. and then this segment right here going through the focus, perpendicular to the axis of symmetry. It's called the lattice rectum. Okay. Yeah, and we're going to be asked to identify all that stuff. And as I mentioned, when p is positive, p is greater than 0, the parabola is opening up in this case. And if the value of p is negative, the parabola will be opening down. Okay. All right, and then the other case is, what if the axis of symmetry is horizontal? Well, then it's just going to be instead of x being squared and y being to the first power, it's the other way around, right? So you switch the x minus h and y minus k. So in case 2, if the axis of symmetry is horizontal, so in this case, the equation in standard form for a parabola is going to be some quantity y minus k squared equals, and once again that coefficient 4p times a quantity with x minus h, where h is the x coordinate, k is the y coordinate of the vertex. So I can say there's h and here's k. Right, so there's the vertex. But this time when y is squared and x is not, the parabola is going to open to the right or to the left, right? The axis of symmetry is horizontal. Right, so the axis of symmetry, here would be y equals k. And then I'm just going to draw the case here where p is positive. Right? If you find the value of this p, you go h plus p, and that'll take you to where the focus is. It'll be a h plus p comma k. Right? And then you go h minus p, and you've got, again, perpendicular to the axis of symmetry. Now, the directrix isn't going to be the y-axis. It just looks like that in my picture, but the directrix is some line. Right? In this case, it'll be a vertical line, x equals h minus p. And then for those ends of the lattice rectum, again, the lattice rectum is going to have a length of whatever the absolute value of 4p is. Then you cut that in half. So I go up 2p to k plus 2p, go down 2p to k minus 2p, and do this from the focus, and you get those ends of the lattice rectum. So h plus p comma k plus 2p, h plus p comma k minus 2p, and then once you get the vertex and those ends of the lattice rectum, you can draw a pretty rough sketch of the parabola opening right there. All right, and if p is positive in this case, the parabola will be opening to the right. If p is negative, the focus will be to the left of the vertex, and the parabola will be opening to the left. Right. Yeah, and again, here's the lattice rectum. All right. So again, we're going to have, it's very, 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 very similar to section 12.3, part 1. Just all that's happened is we've shifted h units right or left and k units up or down. That is all. So the first problem I'm given back in the assignment is, what is the standard form of the equation of the parabola with the focus at -2, -7 halves, and the directrix y equals -5 halves. All right, so I'll start drawing this. All right, so here's the xy plane. Now they give us the focus. Now the focus is not actually on the parabola, right? It doesn't satisfy the equation. But the focus and directrix are more guides as to where the parabola is going to be located. So -2 for the x coordinate of the focus, and then -7 halves, which would be -3.5. So there's -7 halves. And here is the focus. And the directrix is y equals -5/2, which would be -2.5. This is kind of tiny here. But y equals -5/2 is a horizontal line. All right, so yikes, this is going to be very, very tiny. I apologize. But the directrix is y equals -5/2. The vertex, I remember from my pictures, the vertex is exactly halfway between the focus and directrix. Right. So if you're saying, hey, there's -5/2, -7/2, the focus is a y coordinate of -7/2, the directrix is at -5/2, so -6/2, -3 will be the y coordinate of the vertex. And again, I'm very, very sorry about how close this all is. So the vertex will be at the point -2 for the x and -3 for the y, -2 comma -3, and that's your h and k. Also, looking at how the focus and directrix and vertex are all located here, the axis of symmetry is vertical. Right, remember, the axis of symmetry contains the vertex and the focus and is perpendicular to the directrix. The axis of symmetry is the line x equals -2, which is a vertical line. And I pointed that out, right? When the axis of symmetry is vertical, the equation is going to look like this: x minus h squared equals 4p. We just need to find the value of p times the quantity y minus k. Now we know h and k. We just need to know p. So I'm filling this in, right? X minus h squared equals 4p times the quantity y minus k. Now if you see here, the focus is below the vertex. That means p is negative. And you just need to see how many units is that. From -3 to -7/2, that's -1/2. So the value of p is -1/2, right? That's because, again, the focus is below the vertex. If it were above the vertex and the parabola were opening up, then the value of p would be positive. But the parabola has got to be doing this, right? I'm not going to find those lattice rectum points here. We'll do that in later examples. But the parabola has got to be opening down like this. So p's got to be negative. And that's all I need. I need h, k, and p. And now we have the equation. So the quantity x, now minus h would be minus -2. So that's x plus 2, right? X minus -2 squared equals 4 times p. Well, 4 times -1/2, that would be -2. Right? That's 4 times p. Times the quantity y minus k, but minus -3 is plus 3. And there we go. All right, this is what they're asking us for. The equation of that parabola with the focus where it was and the directrix where it was in standard form. And I will select that option. So x plus 2 squared equals -2 times the quantity y plus 3. That's the very first option here. And then after you submit an answer, you'll be told if you're correct or incorrect, and then be given some sort of answer explanation. All right, please read through the answer explanations just to make sure you understand why something was right or wrong, and hopefully you can learn from your mistakes for future questions. All right, so moving on. So here we're asked to graph a parabola with its vertex not at the origin. All right, so I'll do this by hand first, and then we'll go about moving the points the way they want. They ask us to move the vertex and one of the endpoints of the lattice rectum. that's what these 2 points are that we're going to be moving around in this graph here. But first I'll do it by hand. So the equation we're given is, the quantity x minus 3 squared equals negative 4 times the quantity y minus 5. So this is in that form where the x is squared and y is not, right? X minus h squared equals 4p times y minus k, right? We're in this form here. And in this form, remember the axis of symmetry is vertical. The parabola is going to open up or down, not left or right. The axis of symmetry is vertical, a vertical line in this case. I hope it's obvious that the value of h is 3 and the value of k is 5. So that's the vertex. And I'll start drawing this. So 3 for x, 5 for y. And put a solid point there, right? That's actually on the graph. That's actually a solution of the equation, right? The vertex is on the parabola. So it should satisfy the equation. If you put in 3 for x and 5 for y, you're going to get 0 equals 0, which is true. All right, now to find that focus and directrix, right? The axis of symmetry, as I mentioned, is going to be vertical. So it's this line here. Here's the axis of symmetry. I'll just put axis, and it's x equals 3. Right, there's the vertical axis of symmetry, and the focus is going to be on this, and the directrix is going to be perpendicular to this. So now looking at this, the coefficient of the quantity with y here, 4p is negative 4, meaning that p is negative 1. And because p is negative, the negative direction on vertical is going down. So the focus is 1 unit below the below the vertex, right? Here's the focus, and that would be at the point 3, 4. Right. And the parabola is going to be opening down. And if the focus is 1 unit below the vertex, then the directrix is 1 unit above the vertex, and remember, it's going to be a horizontal line here, perpendicular to the axis of symmetry. So the directrix would be the line y equals 6. Right. Now for the ends of the lattice rectum, remember that whatever 4p is, just make it positive, right? Do the absolute value. That's how long this lattice rectum will be. All right, so the lattice rectum will have a length, of 4p is negative 4, so 4 units. Just make it positive, 4 units. And then using symmetry, that just means go from the focus, go 2 units right, 2 units left. Remember, the lattice rectum is going to be parallel to the directrix or perpendicular to the axis of symmetry. So if I go 2 units right, 2 units left, here's the point 5, 4, right, 2 units right of the focus, and 1, 4, 2 units left of the focus, and then here's the parabola. Right, and these should actually be solutions, right? Here's 5, 4, over here, here's 1, 4, and again, check them out. Plug in 5 for x, 4 for y. If you plug in 5 for x, you'd get 4 on the left side. 4 for y, you'd have negative 4 times negative 1 is 4 on the right, you'd get 4 equals 4. That's true. And the same thing over here on the other end of the lattice rectum. Right, here it is, I'll dot it in. Right. 1, 4. If you plug in 1 for x and 4 for y, you get the same thing. You get 4 equals 4. So this is what I'm doing. I'm going to move the vertex to 3, 5, and the other point to either 1, 4 or 5, 4. Right? They asked us to move it to one of the ends of the lattice rectum. So the vertex from 0, 0 to 3, 5. Nice and labeled. And then this point from, I'm going to put this one at 5, 4. There we go. And that's at one of the ends of the lattice rectum. And here's our parabola. Great. All right, so the third objective, identify key components. So we're going to be given an equation, most likely in standard form, and asked to find, probably the vertex or the focus or the directrix or the axis of symmetry or the ends of the lattice rectum, endpoints of the lattice rectum like we are here. So given the parabola below, find the endpoints of the lattice rectum, right? That's that segment that contains the focus that's, parallel to the directrix or perpendicular to the axis of symmetry. And remember, those endpoints of the lattice rectum are also solutions of the equation. Alright, so I'm going to do the same thing I did in the last problem. I'll write out the equation we're given and make a quick sketch of a graph, and we'll find those endpoints of the lattice rectum. Alright, so once again I'm given an equation where the x is squared and the y is not. So that's x plus 2 squared equals negative 28 times y minus 1. Right, so this is in that same form as x minus, that form we saw in the last example. X minus h squared equals 4p times the quantity y minus k. So just like last time, the axis of symmetry will be vertical. Now the vertex should be easy to identify if the equation's already in standard form. Right, the value of h and k. Just think about what would make each side 0. What value of x, what value of y. That'll be a shortcut for that. But x minus h, this is x plus 2, which is the same thing as x minus negative 2, right? So negative 2 is the value of h. And like I said, you can think of the value of x. That would give you 0 over here. If x were negative 2, you'd have 0 over there. And if y were positive 1, right? So 1 for y. K is 1. All right, so the vertex is at negative 2, 1. And that's actually on the parabola. The axis of symmetry is going to be vertical again. Right, so here's the axis of symmetry. I'll just put axis. Right. And then define the, so this is going to open up or down. And then to find the focus and directrix, we need the value of that p. Now, according to this, 4p would be that coefficient here, negative 28. So p must be negative 7. And once again, it's negative, meaning the focus is 7 units below the vertex. So 1, 2, 3, 4, 5, 6, 7. All right. So here's the focus. That's at the point negative 2, negative 6. And the directrix would be 7 units on the other side of the vertex, right? Let's do this here. Y equals 8. If I go from the vertex up 7 units, draw a horizontal line, there's y equals 8. That's the directrix. And, 4p is negative 28. So the lattice rectum will have a length of 28. A length of 28 units. So I cut that in half and use symmetry. So from the axis I go right 14. So that'll be 12. Negative 2 plus 14 is 12. And then negative 2 minus 14 be negative 16. And then just go from the focus. So 12, negative 6, and negative 16, negative 6. those are the ends of the lattice rectum, and right once you got the vertex and the points on the lattice rectum in, you should be able to make a rough sketch. But here's the lattice rectum. Alright, there's 12, -6, and -16, -6. And once again, you can check that these points are actually solutions of the equation, right? If you plugged in 12 for x and -6 for y, it should be a true statement. And if you plugged in -16 for x and -6 for y, it should also be a true statement. I'll leave that to you. But 12, -6, and -16, -6, that's this option right here. Wonderful. Okay. Very same kind of objective, but this time the y is squared and the x is to the first. So now the parabola is going to open, right or left instead of up or down. The axis of symmetry will be horizontal instead of vertical. And once again, we're asked to find the endpoints of the lattice rectum, but this time actually type them in, right? It's not multiple choice this time. Right, so same deal. I'm going to go about it the same way. So here the equation looks like this. We have the quantity y plus 3 squared equals, and then, just the quantity x minus 2, or just 1 times x minus 2. If you want to throw a 1 in front of that, you can. Nothing wrong with that. So this is in this form, y minus k squared equals 4p times the quantity x minus h. And again, if you see something like that, the axis of symmetry is horizontal now. Now the h and the k, right, the vertex should be easy to identify if you realize that it's in standard form like this. Be careful, right? Remember that x coordinate first, y coordinate second. Very often I'll see people make the mistake, they just go left to right and say, oh, -3 and then 2. They go -3, 2. No, it's the other way around. What's with the x? What's with the y? X minus h, h is 2. Y minus k, k would be -3, right, because that's y plus 3. And then put them in the correct order, right? 2, -3 for the vertex. So 2 for x, -3 for y. Right, there's the vertex. There's, one solution to this equation. And the axis of symmetry is now horizontal, right, when y is squared and x is not. So here's the axis of symmetry. I'm just going to put axis. So the focus is going to be either right or left, and again, it depends on the value of p. Right? If p is positive, the focus will be to the right of the vertex. If p is negative, it'll be to the left. Well, 4p in this particular example is 1. So the value of p is 1/4. So I move to the right, so let's say this is 2 1/4, right? Or I should really say 9/4, right? So there's the focus. Move to the right 1/4. Here's the focus at 9/4, comma -3. And then if I move left 1/4, that's 7/4. And this will be a vertical line, the directrix. Right, the directrix will be the line x equals 7/4. And the parabola is going to open to the right. Now those points on the ends of the lattice rectum, remember the value of 4p is 1. That's the length of the lattice rectum. So I cut that in half and go up and down. Go up a half, from -3 to -5 halves, and then down a half from -3 to -7 halves, and there's your 2 points. Go up and down from the focus. And then now I got the vertex and the points on the ends of the lattice rectum. I can draw a very, very, very rough sketch of the parabola. but this point, I'll just write it over here, the ends of the lattice rectum one of them is at, half a unit above the focus, so 9/4 negative 5/2, and the other one is half a unit below the focus, so that the length of the lattice rectum is 1 unit. That's 9/4 negative 7/2, and these are what we're going to enter right here, right? Those ordered pairs. So one of them is at 9/4, comma, negative 5/2. The other one's at, I'm just going to copy and paste this and change the 5 to a 7. 9/4 negative 7/2. Wonderful. All right, moving on. All right, so now this time again we're given some information about some parabola and asked to write the equation of that parabola in one of those standard forms. All right, so here we're told that the focus is at 0, negative 1. So 0, negative 1, there's the focus. Of the parabola, and the directrix this time is a vertical line. It's x equals negative 4. Right. So here's the directrix. X equals negative 4. Alright, so I should be able to tell you where the vertex of the parabola will be very easily. What's halfway between 0 and negative 4 is negative 2. So negative 2, negative 1 is where the vertex will be. Right, so the vertex is, negative 2, negative 1. There's the h and the k when you're trying to write your formula. And then the value of p would be positive. You see how the axis of symmetry, that's another thing I'll notice too. That'll tell me what kind of equation I need to write. Right? The axis of symmetry is horizontal. The axis of symmetry is y equals negative 1. That's horizontal. So the kind of equation I'm writing will have y squared and not x. So it'll be y minus k squared equals 4p times the quantity x minus h, right? And then I just need to know the value of h and k, which I already do. And now I just need the value of p, which again is that, from the vertex to the focus gives you p. And if it's to the right, it's positive. If it's to the left, it's negative. Well, the focus is to the right of the vertex. So p is positive. And how many units is that? That's 2 units, right? So p is positive 2. And now I have everything I need to, and again, I'm not going to find those ends of the lattice rectum here. You can if you want, but I'm just doing this. It's got to open to the right like that. So the equation is y minus k, so y minus negative 1, right, the y coordinate of the vertex, which will be y plus 1 squared, equals 4 times p is 4 times 2, that's 8, and then times the quantity x minus h, but h is the x coordinate of the vertex. X minus negative 2 would be x plus 2. And this is what they want right here, right? The equation of the described parabola in standard form. And which one of these is that? Y plus 1 squared equals 8 times the quantity x plus 2. That's this second option here. Great. All right. So this time graphing a parabola. Once again, I'll do this by hand first, and then we'll come back here and move some points around. Actually, we're not moving any points around. It looks like it's a multiple choice problem. Alright. Instead of moving the vertex in one of those points at the ends of the lattice rectum, we're just doing multiple choice here. Okay, so the equation we're given once again has y squared but not x squared, right? So it's the quantity y plus 1 squared equals, and then negative 4 times the quantity x plus 4. So this is in that form, y minus k squared equals 4p times the quantity x minus h. So the vertex, right, the h and k are negative 4 and negative 1. So negative 4 and negative 1 is where the vertex is. I'll plot that. Negative 4, negative 1. There's the vertex. The 4p is negative 4. So the value of p is negative 1, meaning that now remember this when the y is squared and the x is not, the axis of symmetry is horizontal. So p being negative 1 means the focus is going to be 1 unit to the left of the vertex. So here's the focus at negative 5, negative 4. And the directrix then would be 1 unit to the right, and it'll be vertical because the axis of symmetry is horizontal. And here's the directrix, right, at x equals 3. And the value of 4p is negative 4. So the lattice rectum is going to have a length of 4 units. So I just cut that in half and use symmetry. From the focus I go up 2 units and then down 2 units, and we get the ends of the lattice rectum at negative 5, 1 and negative 5, negative 3. And there's enough to draw a rough sketch of the parabola. So vertex, negative 4, negative 1, and then the ends of the lattice rectum are at negative 5, 1 and negative 5, negative 3, and it's some parabola opening left. So let's see which of the options matches that. That's this very first one. See, negative 4, negative 1 for the vertex. It's opening left. And the ends of the lattice rectum, they've also highlighted at negative 5, 1, negative 5, negative 3. That's that very first option. So I'm not even going to bother looking at the rest. Great. All right. So again, now this time, all right, so now I've done a couple from each objective, I think. I don't want the video to run too long, so I'm going to just kind of talk some of these out loud. Some I'll probably graph, but if they're just asking me for little bits of information, I'm just going to speak it. So here, y plus 3 squared equals negative 2 times x minus 2. The vertex would be at 2, negative 3. 2 for x, negative 3 for y. And it's going to open to the left. Right? The value of p would be negative 1/2. Right? 4p would be negative 2, so p would be negative 1/2. So 2, negative 3, but I move that to the left 1/2 for the focus. So at 1.5 or 3/2, negative 3. And the value of 4p is negative 2, so the value, the length of the lattice rectum is 2 units. I cut that in half to 1 and go up and down. Right? The lattice rectum will be vertical if the axis of symmetry is horizontal. So from the focus, which will be at 3/2, negative 3, I go up 1 unit to 5/2, negative 3, and then down 1 unit to 1/2, negative 3. So 5/2, negative 3. Oh no, I went up and down, so I moved the y coordinate. I apologize. So yeah, the focus is at 3/2, negative 3. I went up 1 to 3/2, negative 2, down 1 to 3/2, negative 4. Yeah, 3/2, negative 2, 3/2, negative 4 would be the endpoints of the lattice rectum. Yeah, sorry, I was adding to the x coordinates. I should have added to the y coordinates because I was moving up and down. Right. Great. And again, with some practice and hopefully after seeing a bunch of these, you'll get the hang of it like this. All right, so another equation, standard form. Find the endpoints of the lattice rectum again. All right, now I'm going to write this one out because this one is not in standard form. Right, this one is not in standard form. Because remember, the standard form for a parabola equation has to have the square by itself. We have the quantity x plus 2 on the left equals 1/20th times the square, the quantity y minus 1 squared. This is not in standard form the way it looks right now, but we can very easily get it into standard form by just simply multiplying by 20. Get the square alone, that y minus 1 squared, so then you'd have the quantity y minus 1 squared equals 20 times the quantity x plus 2. And now it's in standard form. Right, and it's in that standard form, the y minus k squared equals 4p times x minus h, right? So the vertex would be -2 for x and then +1 for y. 4p equals 20, so p equals 5. It's +5, and because this is a y squared, the parabola is opening right or left. This one, it's going to open to the right. This is telling me that the focus is 5 units to the right of the vertex, and I'm going to do this without even graphing. Now if I go 5 units to the right of the vertex, that's just adding 5 to the x coordinate, so the focus would be at 3, 1. And then here's the length of the lattice rectum, right, 20. So that means I'm going to be going up and down 20, right? The lattice rectum should be perpendicular to the axis of symmetry or parallel to the directrix. I'm going to add and subtract 10. I'm going to add and subtract 10 to the y coordinate of the focus. So the ends of the lattice rectum, let's say ends of the lattice rectum are at 311 and 3, -9. And this is what they want us to enter, 311 and 3, -9. And then you can always, of course, double check these, actually make sure that these are solutions of the equation. If I replaced x with 3 and y with 11, if x were 3, that'd be 5 times 20 is 100, right? And then 11 minus 1 is 10, and 10 squared is 100. You got 100 equals 100. And the same thing with 3, -9. Right? Just make sure that those endpoints of the lattice rectum you find are actually solutions of the equation. So 311 and 3, -9. Those should be good. Wonderful. All right, so that objective's done. All right, now back to writing equations where you just need h and k and p. All right, so they give us the focus 6, -1. All right, the directrix is vertical, x equals -10. That means the axis of symmetry is horizontal. So that's why and they already give us the standard form. They're being very kind. So if you take, what's the distance from 6, -1 to x equals -10? Well, that is x coordinate of 6 to an x coordinate of -10. That's 16 units. And the directrix would be to the left of the focus. Alright, so take away 8. -2, -1 would be the vertex. So h is -2, k is -1. So I'd have the quantity y plus 1 squared equals, and then something times x plus 2. I just need to find that coefficient in front. And like I said, p is 8. 4 times 8 would be 32, right? Because the the focus is 8 units to the right of the vertex -2, -1, and this should be good. Y plus 1 squared equals 32 times x plus 2. And again, with enough practice, hopefully this isn't so bad. And I wrote out a bunch of stuff already, so I'm hoping that you got enough information how to do this stuff writing out by hand earlier in the video. Alright, so another one, now they're telling us again to put it in this form. Focus at 5, -1, directrix at x equals -9. This is very similar. You see the focus is to the right of the directrix. So it's opening right. P is going to be positive. The distance between these is 14 units, 9 and 5, right? So take away 7 here. So again, the vertex is at -2, -1. So again, we have h is -2, k is -1, so y plus 1 squared equals some number, and p is 7. 4 times 7 is 28 times, and then x minus -2, or x plus 2. There we go. Y plus 1 squared equals 28 times x plus 2. This should be an equation for the parabola with this focus in this directrix. Great. Okay, and then finishing up the last objective, just graphing. And this is one where actually we're moving the vertex and we're moving one of those ends of the lattice rectum. Now x plus 5 squared equals 8 times y minus 4. The vertex would be -5 for x, 4 for y. Right, so I'm going to move this to -5, 4. There's the vertex. And 4p is 8, so p is 2. The focus would be 2 units above. At -5, 4 would be at -5, 6, and then the length of the lattice rectum would be 8. So I go 4 units right, 4 units left. So instead of -5, 6, move 4 right, that'd be at -1, 6. -1, 6 will be one of the ends of the lattice rectum. And again, double check it. Make sure when x is -1 and y is 6, these give you the same thing, and you'd get 16 equals 16. That's true. All right, so there's your picture. Great, and based on my progress, I should have one more problem. And this is simply find the vertex of this parabola. Wow. Save the easiest one for last. Alright, this is already in standard form. See, the square is alone equals some number times a quantity with x, right? This is in that y minus k squared equals 4p times the quantity x minus h. So the x-coordinate of the vertex would be -10, right, because that's x plus 10, is x minus -10, and the y-coordinate of the vertex would be 5. So the vertex would be -10, 5. That simple. Wonderful. All right, and that should be it for this preview version of this assignment. Now, like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same. The structure should be similar. So I'm hoping that watching me do these here, or talk about these here, helps you in some way when you work on the assignment on your own. And thank you very much for watching.